Good day again to everyone. Uh, our focus today is the discussion of the test statistic in hypothesis testing, meaning we are going now to focus our attention regarding the statistical tools that we are going to use in order for us to test the hypothesis. Okay, so before I'm going to start, may I again encourage everyone to please click the subscribe button as a way of showing support to this channel. Okay, and of course, when you're going to watch this one at the same time, may encourage everyone to please share it to your classmate, to your friends who are needing also an understanding of this topic regarding the hypothesis testing, okay, or especially the computational part in the hypothesis testing in research. Now, this can also be used as a reference in your practical research too, which is called to be the quantitative quantitative research in the senior high. Okay. Now, the very first thing that we are going to discuss is, of course, the Z-test. When are we going to make use of the Z-test? Of course, there are so many considerations that we need to look into. Number one would be when we are going to use the Z-test, uh, our focus regarding the assessment whether the two means or proportions of the data differ significantly. Okay, so meaning if we put this into a question, the question says that is there a significant difference of two means or two proportion? Okay, so that is always the focus of the z-test. It identifies whether there is or there is no significant difference. Another one would be, of course, we consider the sample size. Okay, so that when we are going to use the z-test must have at least a sample size which is 30 or greater than 30. Okay, so greater than 30. Another one, the data are assumed to came from a normal population. Okay, it is a normal population, or the population is presumed to be normal. And the last one would be the population variance is known. Now, if we say that the population variance is known, it will follow that the standard deviation will also be known, or the population standard is also known. Okay, so those are the four consideration that we are going to look into if we plan that we use z-test to test our hypothesis. Okay, now it says in here, of course, our objective is number one, to test whether there is a difference between two means or proportion. Okay, or we test them if this difference is considered to be a significant or not. Another one is to confirm the existing information. There are informations before that is actually true, and that when we are going to apply it today, it might not be true. So meaning we are going to confirm this information if it will still be applicable in today's research. Okay. Another one is, of course, if we confirm the existing information, that is the same as also we are going to verify the theory. Okay, we're going to verify the theory. Now, after having this one, the most important one is, of course, we can formulate an educational guess resulting from anecdotal observation. Okay, so that is the objective of the hypothesis testing. Knowing all those things, when are we going to use the z-test, and of course our objective. Now we have here now the steps in using the z-test. Okay, so here are the steps in hypothesis testing using the z-test. Number one is, of course, to formulate the hypothesis to be tested. Now, when we are going to formulate the hypothesis to be tested, we consider the null hypothesis and at the same time the alternative hypothesis. But when we are going to formulate the null hypothesis, the null hypothesis is the starting point of our investigation or research. Now, after having or after stating now our null hypothesis, as a time we're going to consider this one. Determine the appropriate test or statistical tool to use. Of course, when we determine the statistical test to use or statistical tool to use, we consider the sample size. If we have the sample size which is uh, n is greater than 30, we make use of the z-test. And if n is less than 30, we make use of t-test. And of course, we have also to consider the kind of test that we are going to use, be whether it is one-tailed test or a two-tailed test. Now, you might be asking, what about if the sample size is considered to be 30, exactly 30? When we are going to make use of the z-test, we have to consider that the n must be equal or greater than 30. Okay, so that is for the uh, z-test. For the number 3 step, we have in here, we have to determine the critical value. So that when we say we have to determine the critical value, meaning to say before we are going to start our investigation, these things are, of course, set prior to the investigation, okay? So that we can remove the biases when we are going to have the decision. Meaning, step number 1, number 2, number 3, they must be first be established before the investigation will take place or before the research will take place, okay? Now, when we determine the critical value, there are things that we need to understand. The critical values are as follows, okay? Of course, before we're going to have the critical values, we have to set the level of significance. So we have in here. Now, in research, the level of significance will uh, might start from 1% to 5%, okay? 1% to 5%. And if we consider a bigger level of significance, we consider 10%. But normally, what is being considered is from 1% to 5%. When we are going to choose 1%, the research might probably be related to medical courses, okay? Medical courses, or lesser than 1%, okay? And if we consider increasing our level of significance to 5%, of course, when we consider 5%, more or less the kind of research that we consider in here is uh, social sciences research, okay? Now, we have to consider the critical values that we have to use, okay? Of course, when we are going to consider the critical values, we do also have to understand the meaning of level of significance. Okay, so the level of significance is given in percentages or decimal. So let's say, for example, the 1%, the level of significance is 1%, or in decimal form, your alpha level is 0.01. Now, its critical values with respect to one-tailed test is positive or negative 2.326. Okay, so that is the critical values. Now, the critical values is actually the value of these are actually the z-scores. Okay, these are the standards critical values for the given alpha level, and these critical values are considered to be the z-scores. Okay, Now, what about if our level of significance is 2% or alpha level is 0.02? The critical value for this one, if that is considered to be one-tailed test, is positive or negative 2.054. And of course, if our level of significance is 2.5% or alpha level, which is the same as 0.025, now the critical values, if that is one-tailed test, is positive or negative 1.96. What about if that is the alpha level is 3% or alpha level is 0.03? The critical values is positive or negative 1.881 considering the test is one-tailed. And when we have alpha level of 4% or alpha level which is 0.04, the critical values is positive or negative 1.751 for one-tailed test. And what about the 5% level of significance? The critical values is positive or negative 1.645. Okay? And for the 10, that is 1.282. Okay? So these are the critical values. Now, when we say one-tailed test, meaning to say, when you are going to plot this one in the normal curve, there is only one rejection region. Okay? Be it in the right side or in the left side of your normal curve. Now, what about if that is two-tailed? The rejection region is divided into two. So meaning, if we have an alpha level of 1%, this alpha level will be divided into two so that the rejection region at the right side will be 0.5% and the rejection region uh, in the left side will also be 0.5%. Okay? And of course, the critical values is located at the right side and left side. So that is the meaning of two-tailed test. Number 4, procedure. Of course, this is already the proper computation. Okay? Proper computation. So for one sample group, that is we have Z is equal to the quotient, okay, of sample mean minus population mean over the population deviation, population standard deviation multiplied by the square root of the sample size n. Okay, so that is for one sample group. Now another one is we have the two sample group. For the two sample group, meaning to say there are two samples given and of course two standard or two variance standard standard variance are given. Okay, so we have this one as our working equation and so on and so forth. So you just try to look into and try to memorize. Okay, anyway, uh, if we have this one to be your x bar, that is sample mean, that mu pertains to population mean. Now what about this inverted cube? That pertains to the population standard deviation. And what about this n? That is the same as the sample size. Now in the two sample group, now the only one that you need to identify in here is it's no longer population standard deviation ang given, but what is given is sample standard deviation or sample variance. So this is S represented by S. Okay, what about this one? Inverted Q, that is population standard deviation, population standard deviation. So these are the tools that we are going to make use in the computation. So you just select this one that pertains to, that is related to your problem or to the given or to the situation in the uh, in your data gathering. Okay, number 5 step is of course to make decision after the computation, after using the statistical tool. Okay, so when we are going to divide, when we are going to decide, it says in here, what I use in here, my statement in here is with regards to the normal curve. If the computed value of the z, okay, or the p-value, which is represented by the z-score, computed z-score is within the rejection region, then we reject the null hypothesis. Otherwise, we accept the null hypothesis. Okay. Another one, if the computed value is within the acceptance region, then this must mean then accept the null hypothesis, or you fail to reject the hypothesis. Otherwise, reject the null hypothesis. So these are the decisions, possible decisions that we are going to use. Or it says even in here that when we are talking of the p-value and alpha level, if the p-value computed is less than the critical value or alpha level, okay, you always reject the null hypothesis. But if the p-value that is computed is greater than the critical, the alpha level that is given in the criterion, then we accept the null hypothesis again. If the critical, if the p-value, actual p-value that was computed is less than the critical value, we reject the null hypothesis. But if the p-value that is computed is greater than the uh, critical, greater than the alpha level that is given, then you accept the null hypothesis. So these are the things that we need to understand. Now to further understand the steps, we have to illustrate this one by making use of the problem. Okay, so we have in here a problem. It says in here, in building an arena, meaning to say the dome, or shall we say the Philippine Arena. Now, in building an arena, steel bars with a mean ultimate tensile strength of 400 megapascal with a variance of 81 megapascal were delivered by the manufacturer. The manager tested 50 steel bars and found out that the mean tensile strength is 390 megapascal. The decision for the extension of the contract with the manufacturer depends on the engineer of the manager. Okay, engineers of the manager. Uh, it says in here, test the hypothesis whether there is no significant difference between the two means using a two-tailed test with an alpha level of 1%, or A is equal to, or alpha level is equal to 0.01. That is actually 1%. Okay, now to answer this one, of course, we have to do the step-by-step process so that we will not be confused. Okay, to answer this one, definitely our number one step would be we have to formulate the hypothesis, okay, to be tested. So, what are the hypotheses that we are going to consider? Of course, we have to get the null hypothesis, okay? So, the null hypothesis, it says in here, there is no significant difference between the two means from the population and sample respectively, meaning to say the two means that are being considered in here are the means of the steel bars delivered by the manufacturer, and that is considered to be a population. Okay, so that is 400 megapascal. Now what about the means tested by the manager? That is, we have the 390 megapascal. Okay, so these are the mean that we are talking. Now there is a difference, but of course we try to determine this one if it is significant or not. And so the mathematical or the statistical notation of this one is, it says in here, null hypothesis is equal null hypothesis is when we say that the population mean is equal to the sample mean. So we have in this one, population mean is equal to the sample mean. Now another one in here is we have the alternative hypothesis. For the alternative hypothesis, it says in here, there is significant difference between the two means from the population and sample respectively. So that when we are going to put this one into statistical notation, the alternative hypothesis states that population mean is not equal to sample mean. So that is the meaning. Meaning to say, the difference is significant. Okay, for the alternative, the difference is significant. For the null hypothesis, the difference is not significant. Okay, so that is the those are the hypothesis that we are going to consider. But again, as I've said, when we are talking of the hypothesis, we always consider the null hypothesis. Okay, meaning to say the null hypothesis is the starting point of our investigation. Actually, uh, you cannot see, usually they do not, in research, alternative hypothesis is not stated. It is always the null hypothesis that is being stated. Okay, number two. Okay, in the number two, it states in here, determine the appropriate test statistical tool to be used. Okay, so since it was mentioned in the problem, uh, and the sample size is n is 50, then we make use of the two-tailed test and z test. Okay, and z test. Why? This one is already very clear in the problem. Okay, so why do we make use of the z test? Because the n is greater than 30, or the sample size is considered to be large. Okay, so mind you, when we say n is equal or greater than 30, that is actually we consider the sample size to be large. Okay, to be large. Another one in here is we have in here the statistical formula that we are going to make use. So z is equal to the quotient of sample mean minus population mean over this population standard deviation divided by the square root of n, or actually that is the same as multiplied by the square root of n. Okay, so these are the statistical tool that we are going, this is the statistical tool that we are going to use. Okay, step number 3, critical values. Okay, we have to set the criterion, so that in here, when we set the criterion or critical value, uh, we do also have to put them in, illustrate them in a curve. Okay, so this is the one that I'm mentioning a while back. Okay, now remember that a while back we are talking of the critical values. The critical values is actually the label. The critical values is actually the boundary. Okay, boundary between the acceptance region, the shaded part with blue, and the unshaded one. So that is the critical values, which is the same as in our example, 2.576. So it is located in here. So remember, that is two-tailed, and so the same. The critical values is critical values is also located at the right side. Why? Because that is the same as two-tailed. Now I told you a while back that when that is two-tailed, the alpha level is divided into two. Okay, meaning If that is 1%, 0.005 is located at the uh, left side, okay, and 0.005 is located at the left side. Actually, this is the 0.5% of 1% or half of 1%, okay, half of 1%. So again, to go over the shaded part with blue is the acceptance region. Now, I told you that when we are going to decide and the uh, the critical value that we computed or z-score that we computed is within the acceptance region, then we accept. If the critical the z-score that we computed is within the rejection region, then we reject. So unshaded part in here are the rejection region. Okay, now let's look into the step number 4. So in the step number 4, we will compute now the test statistic. So recall the given. So our population mean is 400 megapascal, and population variance is 81 megapascal. The standard deviation the population standard deviation is the square root of 81, so 9. And the sample mean is 390 megapascal. How about the sample size? 50. So because of this one, it satisfies the one sample test. Then we make use of this kind of formula. Okay, the one sample test. Okay, so notice that our sample mean is to be substituted by 390, which is the sample mean. Now, population mean is 400, that is the population mean. Okay, and of course, population standard deviation is the square root of the variance. That is 81. Okay, so 9. And divided by the square root of n, which is 50. Or actually in the concept of the rational, we get the reciprocal of this one and then proceed to multiplication. That's why the equation that you have seen before is x bar minus population mean over standard deviation multiplied by n. It is because we took the reciprocal of this one. Standard deviation over the square root of n, get the reciprocal, proceed to multiplication, and so it will give you those kind of equation. Now after substituting this one, that is 390 minus 400, that is the same as negative 10 divided by 9, and of course multiplied by 0.50. So let's try to look into. So we have in here negative 7.875. So negative 7, 8.75. Now having this one, this is already the z-score, the actual z-score. Now we will be comparing this one now to the critical values that we already set in the step number 3. Okay, for us to decide for step number 5. So notice we will make a decision. Now if our computed z is negative 7.857, notice that that is located in the left side of the critical value, that is negative 2.576. Okay, so that one. So meaning it is located in the rejection region of the normal curve. Thus, when we say the computed z value is within the rejection region, then we can make a decision saying that since the computed Z value is within the rejection region, then we reject the null hypothesis. Or this can be stated in another way. Since the computed Z value, which is negative 7.857, is less than the critical value, that is negative 2.576, then we reject the null hypothesis. So those are the decisions that we are going to do. Of course, when we are going to decide, we have to interpret the meaning. Okay? So when we are going to interpret that one, it says in here, since the computed Z value is less than the critical value, it means that there is insufficient, okay? There is insufficient evidence to support the acceptance of the null hypothesis. So if there is insufficient evidence to support the acceptance of the null hypothesis, then it is but proper to reject the null hypothesis. Uh, I hope that with this illustration of this Z test in the computation of the test statistic, you understand the problem. Okay, so before I will close this one, or before we end, may I again encourage everyone to please consider supporting this channel by clicking the subscribe button, okay, and sharing this one to your classmate. You expect another example, another application of the Z-test, okay? So, uh, thank you and more power. I hope you understand my lesson. Thank you and more power.